the Mediterranean Sea. It is the cradle of civilization, a turquoise jewel nestled between three continents. When you think of it, you probably imagine the sun-drenched beaches of the Amalfi Coast, the white cliffs of the Greek islands, or a gentle, salty breeze rolling over a vineyard in southern France. It is a place of life, leisure, and history. To us, it seems permanent, a fixed, eternal feature of our planet's map. But appearances are deceiving. If you were to rewind the clock just a fraction of Earth's geological history, about 6 million years, which is practically yesterday on a cosmic scale, this paradise didn't exist. In its place was something that sounds like the setting of a post-apocalyptic science fiction movie, a place so hostile, so alien, and so violent that if you stood there today, you would die in minutes. The reality is that the Mediterranean is not a permanent ocean. It is a geological hostage, trapped between the crushing jaws of the African and Eurasian tectonic plates. And once upon a time, the ocean simply vanished. To understand how a body of water that covers 2.5 million square kilometers can just disappear, we have to look at how fragile its existence really is. The Mediterranean is what we call a concentration basin. It sits in a hot, dry region of the planet where the sun beats down relentlessly. Every single year, the sea loses more water to evaporation than it receives from rainfall and rivers combined. If you were to cut off the Mediterranean from the Atlantic Ocean today, the level of the sea would drop by about 1 meter every year. And that is exactly what happened. About 5.9 million years ago, the Earth's crust shifted. The connection between the Atlantic Ocean and the Mediterranean, the narrow Strait of Gibraltar, was severed. Tectonic activity pushed the seabed up, and perhaps sea levels globally dropped due to growing ice caps. The result was a catastrophe known as the Messinian Salinity Crisis. It sounds like a dry academic term, but the event itself was one of the most dramatic environmental disasters in the history of our planet. Imagine the Strait of Gibraltar not as the open gateway it is today, but as a massive natural dam. With the tap turned off, the Mediterranean began to die. The sun continued to punish the water, turning it into vapor, but there was no fresh supply from the Atlantic to replenish it. The sea began to shrink. It didn't happen overnight, but on a geological timescale, it was a bee of an eye. As the water evaporated, the sea receded, leaving behind vast, white plains of salt. We aren't talking about a few drying puddles. We are talking about the evaporation of nearly 4 million cubic kilometers of water. Scientists have found evidence of this event buried deep beneath the modern seafloor. There are layers of salt and gypsum, minerals that only form when seawater dries up to 3 kilometers thick in some places. These are the ghosts of a vanished ocean. Calculations suggest that at the height of this crisis, the Mediterranean was losing the equivalent of 29 dead seas every single year. As the water retreated, it revealed a landscape that defies human imagination. The Mediterranean Basin transformed into a deep, dry bowl, and deep is an understatement. The abyssal plains of the Mediterranean sit at depths of up to 5,000 meters. That is 5 kilometers vertically down. To put that into perspective, if you were to take Mount Blanc, the highest mountain in the Alps, and turn it upside down, it wouldn't even touch the bottom of this dry basin. Or think of it this way. Typical commercial airliners fly at about 10 to 12 kilometers altitude. The bottom of this dry sea was half the distance to the cruising altitude of a jet, but downwards into the crust of the Earth. This created an environment that is technically on Earth, but physically alien. If you could time travel back to this period and stand on the bottom of the dry Mediterranean, the first thing you would notice, right before you collapsed, would be the heat. And not just the heat of the sun. We are talking about the physics of the atmosphere. As you go higher up a mountain, the air gets thinner and colder. We all know this. But the opposite happens when you go down. As you descend into a deep pit, the weight of the atmosphere above you compresses the air at the bottom. This compression generates heat, a phenomenon known as adiabatic heating. At 5,000 meters below sea level, the air pressure would be crushing, about 1.7 times higher than at sea level. The air would feel thick, heavy, and syrupy in your lungs, and it would be hot, unbearably hot. Models suggest that during the summer months, temperatures on the floor of this dry basin could have soared to 80 degrees Celsius. That is 176 degrees Fahrenheit. This is not a temperature you can survive. It is hot enough to slow cook proteins. It is hot enough to melt the rubber soles of your shoes into the salt beneath your feet. This was a hellscape of jagged salt crystals, towering gypsum canyons, and brine lakes that were so salty no life could exist in them. Dust storms, whipped up by winds falling from the surrounding continents, would have swept across these abyssal plains. Because the air was so dense at that depth, these storms would have been more powerful than anything we experience on the surface, carrying heavy sand and salt particles that would scour anything in their path. It was a world of blinding white salt and suffocating heat, a vast, empty scar on the face of the earth. Obviously, for the marine life that had called the Mediterranean home, this was an apocalypse. It was a mass extinction event that we rarely talk about, as the water grew saltier and saltier and then simply vanished. 90% of the endemic species were wiped out. Great coral reefs that had thrived for millions of years were bleached and then left high and dry, turning into fossilized, crumbling stone. Fish, mollusks, and marine mammals were pushed into smaller and smaller pools of brine until they simply couldn't breathe or swim. The ecosystem collapsed entirely. But nature, in its ruthless efficiency, abhors a vacuum. While the sea died, the land seized the opportunity. With the water gone, the barriers between Africa and Europe vanished. Bridges of land emerged from the deep, connecting continents that had been separated for eons. The dried seabed became a highway for migration. This period saw a bizarre biological interchange. Animals from the lush jungles and savannas of Africa began to venture north. Imagine standing on a cliff edge in what is now Sicily, looking down into the vast, salty canyon below. You might have seen herds of ancient hippos trudging across the salt flats. You might have seen elephants, ancestors of the modern giants, navigating the treacherous terrain to reach the forests of southern Europe. It wasn't just a migration, it was an invasion. Rodents, antelopes, and large predators used these new pathways to colonize new territories. But even for them, the crossing would have been a perilous journey through a death zone. They would have had to stick to the margins, avoiding the furnace-like heat of the deepest basins, skirting the edges where rivers flowed down from the continents. And speaking of rivers, the drying of the Mediterranean had a strange and violent effect on the fresh water flowing into it. Consider the Nile. It is the longest river in the world, the lifeblood of North Africa. Today, it flows leisurely into the sea at the Nile Delta in Egypt. But 6 million years ago, the sea it flowed into was gone. The mouth of the river suddenly found itself thousands of meters higher than the bottom of the basin it was feeding. Gravity took over. The water began to cut down into the bedrock with the force of a geological buzzsaw. The Nile carved a canyon that would rival the Grand Canyon in Arizona. But this canyon isn't visible on any modern map. Why? Because it is buried. Deep beneath the bustling streets of modern-day Cairo, beneath the pyramids and the Sphinx, lies a ghost canyon. Geological surveys have found this massive gorge, filled in with sediment over millions of years. It plunges 2,500 meters deep, that is 8,200 feet. Think about that for a moment. If you could strip away the sediment and the city of Cairo today, you would be standing on the edge of a precipice 2.5 kilometers deep, looking down into a darkness carved by the ancient Nile as it raced to reach the bottom of the dry Mediterranean. This invisible scar is one of the most potent reminders of just how low the sea level really fell. This chaotic state lasted for hundreds of thousands of years. The basin may have partially refilled and dried out again in cycles, creating a fluctuating environment of salt lakes and deserts. It was a stable, albeit deadly, status quo. But geology is never static. The forces that had closed the Strait of Gibraltar were still at work, and the Atlantic Ocean was still there, pressing against the gates. The Atlantic is vast and powerful, and it was sitting kilometers higher than the floor of the Mediterranean Basin. A simple earthen dam, no matter how wide, can only hold back the weight of an entire ocean for so long. About 5.33 million years ago, something changed. Perhaps another small tectonic shift cracked the barrier. Perhaps rising sea levels in the Atlantic caused the water to overtop the ridge. It likely started small, a trickle of water, a stream flowing over the rock barrier connecting Morocco and Spain. But water moving downhill has a compounding effect. It erodes the rock. It digs its own channel. The more water flows, the wider the channel gets. The wider the channel, the more water flows. It is a vicious cycle of erosion. The stream became a river, the river became a torrent, and then the dam broke. We often use the word flood to describe heavy rain or a river bursting its banks. But what happened next makes the biblical story of Noah look like a minor plumbing issue. This was not a flood, it was a planetary reset button. The Atlantic Ocean didn't just flow into the Mediterranean, it crashed into it. The barrier at Gibraltar collapsed, creating a breach that allowed the ocean to pour into the empty basin with a violence that is difficult to comprehend mathematically, let alone visually. For a long time, scientists thought this refilling was a slow process, a giant waterfall that took millennia to fill the tub. But newer computer models and sediment analysis paint a much more terrifying picture. The evidence suggests that the majority of the Mediterranean refilled in an impossibly short amount of time. We aren't talking about thousands of years. We aren't even talking about centuries. Imagine standing on a peak in the Atlas Mountains of Morocco, looking north. You would have heard it before you saw it. A low-frequency rumble, vibrating through the bedrock, louder than thunder, constant and deepening. Then you would have seen the white mist rising, a cloud of spray reaching kilometers into the atmosphere, generated by the collision of billions of tons of water hitting the dry basin floor. The Zanclean flood had begun. The water didn't trickle in. It roared down a ramp of solid rock that was kilometers wide, moving at speeds that would strip the flesh from your bones. The sheer weight of the water was so immense that it actually triggered earthquakes as it slammed into the empty seabed. The seismic shocks would have caused landslides all along the basin, sending massive clouds of dust and salt billowing up to mix with the incoming spray. It was a chaotic slurry of mud, salt, and ocean water, churning at speeds of over 100 kilometers per hour. If you had been a creature living on the floor of the basin, perhaps one of those ancestors of the hippo grazing near a brine lake, you wouldn't have even known what hit you. One moment, silence and heat. The next, a wall of water moving faster than a car on a highway, obliterating everything in its path. But how much water are we actually talking about? To understand the scale, we have to look at the discharge rate. The Amazon River is the largest river on Earth today. It discharges about 200,000 cubic meters of water per second into the Atlantic. That is an impressive amount of water. The Zanclean flood? At its peak, it is estimated to have discharged 100 million cubic meters of water per second. That is 500 Amazon rivers combined. Or, to put it another way, imagine 1,000 Niagara Falls, all pouring into the same hole at the same time, but infinitely more powerful. This influx of water was so massive that it actually affected the rotation of the Earth slightly due to the redistribution of mass. It was a hydrological bomb going off in slow motion. And as the water poured in, it began to rise. Fast. In the deepest parts of the basin, the water level rose by more than 10 meters per day. Imagine building a house on the coast, and the next morning the ocean is in your attic. There was no escaping it. Any animal that had migrated down into the basin was trapped. The rising tide would have chased them up the slopes, relentless and unstoppable. This wasn't just a local event. The amount of water required to refill the Mediterranean was so colossal that it drained the global oceans. Sea levels around the world, in the Caribbean, in the Pacific, in the Indian Ocean, dropped by about 10 meters. A beach in Hawaii would have suddenly extended outwards by hundreds of meters because the water was being sucked away to fill the hole in Europe. The flood tore through the landscape, scouring the seabed and reshaping the geography of the region forever. It washed away the salt deserts, dissolved the gypsum canyons, and buried the ancient river channels. But amidst this destruction, something fascinating was happening. The flood wasn't just bringing water, it was bringing life, and it was creating a unique evolutionary laboratory that would give rise to some of the strangest creatures the world has ever seen. The violence of the Zanclean flood was the labor pain of the modern Mediterranean. But as the water stabilized and the roar of the falls at Gibraltar finally quieted down to the gentle current we know today, the story didn't end. In fact, for the life forms trapped on the newly formed islands, the strange journey was just beginning. As the roar of the Atlantic tearing through Gibraltar settled into a rhythmic planetary heartbeat, the Mediterranean Basin was no longer a dry, alien hellscape. It was a sea again. But the sheer magnitude of the Zanclean flood had done more than just fill a bathtub. It had fundamentally altered the mechanics of the Earth itself. When we talk about the flood, the numbers are so astronomical they almost lose meaning. So let's ground them. We mentioned the discharge rate of 100 million cubic meters per second. To visualize that, imagine the raw power of Niagara Falls. Now, clone that waterfall 33,000 times and have them all crash down at once. That is the level of violence we are talking about. It was a force capable of shearing away entire cliffsides, creating seismic tremors that would have registered on seismographs thousands of miles away if there had been anyone around to read them. The water didn't just rush in. It surged at speeds estimated at 40 meters per second. That is nearly 90 miles per hour. This wasn't a rising tide. It was a liquid bullet train. If you were standing on the abyssal plain when the water arrived, you wouldn't drown. you would be pulverized by the shockwave of air being pushed ahead of the water before the liquid even touched you. And then, silence. Or rather, the new quiet of a settled ocean. But while the basin was now full, the consequences of this event rippled outward, affecting the entire globe. You see, taking that much water out of the global ocean to refill the Mediterranean had a measurable impact on sea levels worldwide. The Atlantic, the Pacific, and the Indian Oceans all dropped. This massive redistribution of mass likely tweaked the Earth's rotation and, more importantly, its climate. We have seen this happen before in geological history. Take Lake Agassiz, for example, a massive prehistoric lake in North America that burst its banks towards the end of the last ice age. When it emptied fresh water into the ocean, it disrupted ocean currents so severely that it plunged the planet into a big chill, a period of extended cold lasting over 1,000 years. The Zanclean flood was a similar beast, but in reverse. By siphoning off a massive volume of ocean water, it altered salinity levels and ocean circulation patterns globally. While the precise details are still debated by climatologists, it is highly probable that the refilling of the Mediterranean triggered a cooling spell, a distinct shift in the global weather systems that would have been felt by creatures as far away as Antarctica or the Asian steppes. The Earth is a closed system. You cannot drastically change the map of Europe without the rest of the planet feeling the shivers. But the most fascinating consequence of this cataclysm wasn't the weather. It was the biological explosion that followed. As the waters rose, the high points of the ancient dry basin were not submerged. They became islands. Sicily, Sardinia, Crete, Cyprus, and thousands of smaller archipelagos were cut off from the mainland. The animals that had migrated down into the basin during the dry period and survived the initial flood found themselves trapped on these new, isolated landmasses. And this is where evolution decided to get weird. Biologists call it the island rule or Foster's rule. When animals are isolated on islands with limited resources and fewer predators, they change. Large animals tend to shrink to require less food, insular dwarfism, and small animals, freed from the threat of large predators, tend to grow massive, insular gigantism. The post-flood Mediterranean became a gallery of evolutionary monsters and marvels. Imagine walking through the forests of ancient Sicily a few million years after the flood. You hear a rustling in the bushes. You expect a boar or perhaps a deer. Instead, out steps an elephant. But this isn't the majestic titan of the African savanna. This is Paleoloxodon falconeri, the Sicilian dwarf elephant. It stands roughly 1 meter tall at the shoulder. It is the size of a large dog or a miniature pony. You could effectively look this elephant in the eye without tilting your head. It is adorable, absurd, and perfectly adapted to life on a small island where being huge is a liability. But the cuteness ends there, because while the elephants were shrinking, other things were growing. Look up at the sky. Soaring above these dwarf elephants were birds that defy logic. This was the domain of Cygnus falconeri, the giant swan. But swan is a gentle word for this creature. It was a tank with feathers. From tip to tip, its wingspan stretched nearly 3 meters, 10 feet. Standing on the ground, it would have been taller than the dwarf elephants it shared the island with. This bird was so heavy that it likely spent most of its time walking rather than flying, a feathered fortress that had no reason to fear anything. The predators were equally bizarre. On the island of Sardinia, the otter, usually a sleek, playful river dweller, evolved into Megalenhydris. This wasn't an otter you would want to hold hands with at an aquarium. It was the size of a wolf, perhaps even a jaguar, a hypercarnivore that hunted in the water and on land. It was the apex predator of its ecosystem, a king in a kingdom of distorted sizes. There were giant owls, massive cranes, and dormice, rodents that are usually palm-sized that grew to the size of house cats. The Mediterranean islands became a through-the-looking-glass world where the rules of size were inverted. None of this biological creativity would have been possible without the Zanclean flood. It was the barrier of the water that allowed these experiments to run their course. The flood didn't just restore the sea, it created thousands of isolated petri dishes for evolution to play in. However, as we marvel at the history of this sea, we must remember one crucial fact: geology does not stop. We tend to look at the map of the world and assume it is finished. We think the Mediterranean is a permanent fixture. It is not. The forces that created the Messinian Salinity Crisis haven't gone away. They are just moving in slow motion. The African tectonic plate, specifically the Nubian plate, is still moving northward. It is crashing into the Eurasian plate at a rate of about 2 centimeters per year. That might sound like nothing, It's roughly the speed your fingernails grow. But over millions of years, it is relentless. The Mediterranean Sea is technically in the process of closing. The layout of the continents is slowly squeezing it out of existence. And the Strait of Gibraltar, it is still the sea's Achilles heel. It remains a narrow, shallow connection, only about 14 kilometers wide and a few hundred meters deep at its shallowest point. It is a fragile lifeline. If sea levels were to drop again due to a new ice age, or if tectonic uplift were to raise the seabed at the strait just slightly, the dam could return. The connection to the Atlantic could be severed once more, and if that happens, the cycle restarts. The evaporation will begin. The water level will drop by a meter a year. The harbours of Marseille, Genoa, and Barcelona will dry up. The beautiful islands of Greece will merge into a single arid landmass. The salt deserts will return. But this time, the stakes are different. 6 million years ago, the only witnesses to the drying were ancient apes and migratory birds. Today, the Mediterranean Basin is home to over 500 million people. It is one of the most densely populated regions on Earth. It is a hub of global trade, agriculture, and tourism. Imagine the geopolitical nightmare of a receding sea. What happens when the maritime borders vanish? What happens when the fishing fleets of Italy and Tunisia find themselves driving trucks across a salt flat to meet in the middle? What happens to the climate of southern Europe when the moderating influence of the water disappears, replaced by the radiating heat of a deep salt bowl? The vineyards of France and Italy would likely scorch. The rainfall patterns that feed the crops of North Africa would vanish. It would be a civilization-ending event for the region. Fortunately for us, geological time is mercifully slow. We don't need to worry about the Mediterranean drying up next Tuesday, or even in the next few thousand years. The closing of the basin is a problem for our distant descendants, millions of years down the line. But the story of the Zanclean flood serves as a powerful reminder. It reminds us that our planet is dynamic, violent, and indifferent to our presence. We build our cities on the coastlines, assuming the water will stay where it is. We map our borders on mountains and rivers, assuming they are eternal. But the Mediterranean teaches us that the map is just a snapshot in time. A blue expanse of water can become a burning desert, and then a blue expanse again, all within the bee of a geological eye. So the next time you look at a photo of the serene, blue waters of the Mediterranean, or perhaps when you are lucky enough to dip your toes into its surf, remember what lies beneath. Remember the salt canyons buried under the sediment. Remember the dwarf elephants that once roamed islands born from a flood. And remember that you are standing on the edge of a temporary ocean, a beautiful, fleeting anomaly in the shifting puzzle of our planet. The Mediterranean died once, and one day, far in the future, it will almost certainly die again. But for now, let's just enjoy the view while it lasts.